Hello, everyone. Welcome to our deep learning workshop, and let's welcome Sean Mather, your workshop's host for today's session. Sean is a deep learning startup founder and just received his master's in computer science from UCLA. He will be teaching you all about machine learning, and there will be time for questions and answers in the end. Hopefully, this workshop will guide you in your brainstorming and innovation to submit for the Terris Challenge. And remember, feel free to ask questions through the chat, which Ashita and Ruth will be monitoring throughout. As always, for each workshop you attend, your name will be automatically entered to be in our workshop raffles.
All right. Well, hello, everyone. It's really cool to be here. My name is Sean. I am just graduated from UCLA with a master's degree in computer science. I love deep learning, which maybe some of you know what that is. Some of you may have no idea, but it is the future. And I mean this very seriously, it's the future of the world. So I'm here to try to see if I can inspire any of you to go down this path. All right. So again, like I said, I'm a recent master's graduate from UCLA Computer Science. I'm also a deep learning startup founder. I have a startup that focuses on healthcare data, and we could talk about it too. It's also based upon some deep learning technologies. I'm a huge nerd. I found this out actually in college. I went to American high school before UCLA, and there it was just like, oh, I have to grind out homework assignments every single day. So I didn't really care much about what I was learning. But I went to college, and that all changed for me. I fell in love with math, computer science, deep learning, and artificial intelligence. Really, really cool areas. I've studied, taught, engineered, and researched in the area of deep learning. I used to be a TA at UCLA for a deep learning neural networks class. And please believe me when I say this, deep learning is going to power the future. You may not realize it now, but a lot of the technologies that we use every day and take for granted are actually powered by neural networks and deep learning. And we're really at the cusp of a renaissance in deep learning. Most people don't realize this yet, but what we're about to see in the next 10 years, 20 years is going to be a really, really weird world, powered by deep learning, challenged by some of the problems with deep learning. And it's really exciting, and it's important to at least be somewhat familiar with what's going on. And that's my aim for today. My hope is to get you excited about deep learning, and if I'm lucky, maybe inspire a few of you to go down this path. Like our moderator said, if you have any questions at all, please message on the chat, and hope the moderators can feel free to interrupt me and ask me those questions. I'd love to make this a dialogue rather than me just speaking, but I'm happy to do either. Okay. So, of course, the first question is, what is deep learning? So very crudely, deep learning is a tool for teaching computers how to reason, identify patterns, generate text, generate images, and so much more that we're only just starting to crack the surface in. Specifically, deep learning is a particular technique of artificial intelligence where we're trying to mimic the human brain, and it does so using quote unquote artificial neural networks. And what we do is that we take these artificial neural networks that are inspired by our brains, and we teach them through examples. For example, if I wanted to build an AI that would it be able to predict what somebody's age is based upon their face, I might start off with a bunch of images, maybe 10,000 images of people's faces, and each image would be labeled with their age. And what a neural network is designed to do is to try to look at those images and identify what are the patterns to look for to recognize that this person is aged 13 years old, 15 years old, 40 years old. And so these neural networks are really good at recognizing these patterns, extracting features from the inputs, and try to draw reasonable conclusions from that data. So where is deep learning relevant today? If I'm sure a lot of you are familiar with smart home technology. I have a Google Home at my house that probably listens to us when we don't know it. But it's really an impressive and amazing technology. It's able to recognize that, say, if I say, okay, Google, it'll recognize that this person is trying to talk to me. And I can say commands like, hey, can you put on my schedule that I have a presentation this upcoming Thursday? It is smart enough to take my audio waveform, convert it into text, and then take that text and actually interpret meaning from that text and understand that I'm trying to ask it to schedule an event for me, or to change the temperature in the house, or look outside my doorbell camera or something like that. And this technology is just going to get more and more complex and more involved with our homes as time goes on. So this is really one application of deep learning. Other applications is basically face recognition. You can look at an image and draw bounding boxes around somebody's face to recognize who's there. Kind of important technology if you're trying to be, I don't know, Snapchat or Instagram and trying to like put weird filters on people's faces. You need to be able to recognize where those faces are. Self-driving cars, another really big and cool tech that's upcoming. A self-driving car has to have many cameras, be able to look around its environment and see, what is there. You need to be able to recognize cars, pedestrians, lights, different signs, and also know the distinction between each of these objects. You shouldn't confuse a car for a pedestrian or vice versa. You should be able to recognize that the speed limit sign says 65, or there's a stop sign. All important and difficult challenges, but are being solved right now by neural networks. Another really cool technology is recolorizing black and white photos. All of these photos are originally taken in black or white film, and artificial neural networks are able to recolorize them. Seems like this shouldn't be possible, but because there shouldn't be enough information. But what these neural networks do is that they look at, you basically feed in a bunch of examples of pictures we take today, and we show them the black and white versions of them. And they learn the mapping from black and white images to colored photos. Then when you give it a brand new photo, a brand new black and white photo, it'll try to infer what the corresponding colorized version will look like. So really powerful technology and really powerful techniques. This one's really cool. You can have two different images, and you can take the second image, the style of the second image, and apply it to the first. So you get really cool and beautiful artwork generated by these neural networks. This was created by Deep Dream, if anybody knows what that is. Being able to generate faces, human faces. This one is really cool to me because you can see all these images of people and you're slowly interpolating all these faces. None of these people here exist. They're completely made up by a neural network, invented by a neural network. It's really cool because each of these images is a point in this really high dimensional space. And you can, if you move forward, you might be adding glasses to the face. If you move backwards, maybe you're making a stronger cheek line. Move to the right and you're making them older, move to the left and you're making them younger. And it's not just 3D, it's like very high dimension, like thousands of dimensions. So it's really cool tech here. And then of course, stuff that is relevant to today, like face mask detection. Are you able to detect whether someone is wearing a mask or not? So tons of applications. Any questions on applications? Okay, if you do, feel free to put it in the chat. So let's talk about what are neural networks. So I am not a neuroscientist. I'm a computer scientist, but I will do my best to try to give the layman's version of a biological neural network and where the inspiration for neural networks came from. So in a biological neuron, we have a single neuron has a bunch of dendrites, and these dendrites accepts incoming signals from other neurons. So basically how we can model this is we have a bunch of inputs like x1, x2, x2, xn. And these are all the input signals the neuron is receiving. Each of these neurons have different strengths, so they come with a different level of strength from that signal. And certain neural connections are more important than others. The axon hillock will take all these input signals and sum them up in like a sort of summation, a weighted summation of all the inputs. And then finally, the output will be some sort of like 1 or 0 strength output. And you might have several outputs here, like y1 through ym. And this is the very crude approximation of what a biological neuron does. And it turns out that this is an incredibly powerful model for us to use. So based upon that, we create this artificial neuron. So we have all these inputs, just like the biological neuron does, x1 through xn. And they're all being fed into this summation. For those of you who may not know, sigma is like the summation symbol. And so we're basically going to be adding up all these inputs. But some inputs are more important than others. So we have to keep that, we have to factor that in. So certain connections are stronger than other ones. So you have associated weights with each connection. And what you do is you're going to multiply each input with the corresponding weight before summing everything up. Like that. And this is like W1 times X1 plus W2 times X2 and so on. And finally, we need to put an output. So what we'll do is we'll say, okay, if the output is strong enough, we're going to output basically a 1. And if the output is not that strong, we're going to output a 0. And we'll have some sort of like smooth continuous function between them. So this is our sigmoid function. And this is the essence of an artificial neuron. And it's the fundamental building block to neural networks. You can also rewrite this as a dot product of vectors if anybody's done vector math and stuff. This is a lot. I'm not like, this may be a lot, and I'm not expecting you to suddenly like understand everything I'm saying here, but like I just want to illustrate what is going on fundamentally in these neural networks. And so once we have that kind of building block, we can start building layers of neurons where each one of these is a neuron doing the same function, but just for m different functions here. So each of these neurons is the exact building block from the previous slide. And we can actually rewrite this as a matrix multiplication. Turns out linear algebra, matrices, vectors, these are all really important concepts for deep learning if you want to dive into the mathematics of it. But the details of it are irrelevant. And once you can have layers, neurons, you could take one layer and make it input to another layer, and the output of that layer will be the input to the next layer, and you can start stacking them. And then you start getting this really complex, you're able to model very complex functions, like you have an image of a number. What number is written in that image? And so this kind of deep neural network architecture is able to solve problems like that. Again, don't be overwhelmed. These are advanced topics, and most likely you guys don't yet have the fundamental mathematical tools yet to cover everything here. There's a lot more going on. There's stuff from multivariable calculus and doing optimization and how to train neural networks and these things like this. But don't be overwhelmed. All great things take time. And I still believe that you can still work with this stuff even at the level you may be at right now. Was there something in the chat? I saw something pop up.
Oh yeah, there was a question in the chat. Should I read it? So the question is,
please.
Oh yeah, so the results from those neurons will send a specific signal for a certain image or property of the object the machine wants to detect.
Right. So the neuron will be looking for a specific pattern in the input image. So if you have an image of a face or something, and you're trying to recognize, if you're trying to recognize like somebody's age based upon an image of their face, the input layer will be the image of the face. And then maybe one of the neurons is looking for a particular pattern in the input that might be informative about what their age is. For example, maybe you're looking at their cheek structure or something. Maybe that might be informative. Or maybe that neuron is trying to look for wrinkles on their face. That might be informative that they're old. All these neurons are looking for different kinds of features that might be informative for figuring out the final answer. And the deeper number of layers we have in our neural network, the more complex and fine-grained our features can be, which usually leads to better results. In actuality, I'm kind of lying, because these neurons are not going to be looking for wrinkles necessarily. They're going to be looking for patterns and images that we may not even understand as humans, but the computer does. So that's actually one of the challenges, actually trying to interpret what features these neural networks are learning is an open problem, really. It's not something that we can really interpret. I got a direct message. Let's see here. Is a neural network used in those apps that show what you might look like N years from now? Very possibly. It certainly can. I know that there's a lot of different machine learning techniques. You have like artificial intelligence very broadly. And one subset of artificial intelligence is called machine learning, where you're trying to learn patterns from data. Deep learning and neural networks is a specific kind of machine learning application, but there might be other machine learning methods that could power those apps that you're talking about, that might show you what you look like 10 years from today. I imagine deep learning, though, would provide the best results out of most methods. That was a good question. Any other questions?
I think we're good.
Okay. I've lost my mouse and I can't. No. I'm just trying to get rid of this chat. Okay, good. All right. So yeah, let's move on. So what areas of deep learning are interesting right now? So computer vision is definitely one of the big areas. This is one of the areas that really started to revitalize the interest in artificial neural networks. You might have an X-ray and you want to detect whether this X-ray shows signs of cancer. You might want to have an image of a face and recognize that it's your face. If you're using iPhone, you'll know facial recognition from Face ID. That's powered by a neural network. There's loads of other applications. I know that there's actually AI powered by neural networks that perform better diagnoses than doctors do in some specific areas. I think like radiology and things like that. So computer vision, very interesting area. And a lot of the starter tutorials in deep learning, if you're interested in working this area, start with computer vision. Natural language processing, another very hot area that I'm personally trying to get into, involves like speech to text, smart assistants. Basically, it's anything to do with parsing text of some kind and interpreting meaning from it, translating English to Spanish or vice versa. All these like non-trivial operations that you would do on text fall within the realm of NLP. Deep reinforcement learning, also a very cool upcoming area. Researchers have basically taken AI and trained them to play the game of Go, chess, different kinds of games, and they basically like are learning in the way that animals do, in the sense that you perform an action, you receive a reward or a punishment, and these AI are trying to maximize the reward they get. So they learn strategies to play these games in a way that rewards them the most and leads to them winning. So that's also really cool field. Adversarial examples, very scary field. I actually did my master's thesis in this, area. It's about tricking neural networks into doing the wrong thing or making the wrong prediction. For example, if you're driving a Tesla of some kind and your self-driving Tesla looks at a stop sign, it should know to stop. But some researchers are able to show that if you put these black and white stickers on these stop signs in very strategic locations, you can actually fool the Tesla into believing that the stop sign is an 80 miles per hour speed limit sign. So you can basically cause havoc and by tricking these neural networks into making the wrong predictions. So this is a whole area. It's really interesting, very scary. Generative adversarial networks, also super, super cool. If you ever heard of deepfakes, deepfakes are powered by generative adversarial networks. Basically, you can, well, they're called, so GAN, GANs. GANs have a lot of applications. Deepfakes are one of them, where you can put somebody else's face on someone else in a video. So like I don't know if you guys know the show Full House, but they basically took, oh man, what's the guy's name from Parks and Rec? Ron? I forget, but they took that guy's face, the mustache, and they put him on every single character in the video. So you see like the Full House intro, but they're all old men. So it's just, at least the funny stuff like that. Recolorizing black and white photos is another application. Generating faces of people who don't exist. My particular startup is trying to use generative adversarial networks to basically try to generate medical data that's not tied to anyone's actual identity. So if you take a bunch of medical data, you can't just share that medical data because of patient privacy, but the world would move so much faster. Medical innovation would be so much faster if you could do that, if you could just share data. So what we're trying to do is use a generative adversarial network to learn what medical data looks like and then generate realistic looking synthetic medical data and share that synthetic data instead. That's my TLDR of my company. But yeah, so all these subfields, super interesting. So I think that there's no possible way for me to really give you a robust understanding of neural networks in a small time frame like this. So what I've opted to do is try to come up with a list of tutorials that will help you, give you a background in this area. So these are deep learning concepts, or just understanding the conceptual fundamentals of deep learning. There's this YouTube channel called 3 Blue 1 Brown, very, very good at expressing very complex ideas in a very simple way. I would highly recommend. Also, all these links I'll be sharing with the mods, so they'll be sharing it with you guys. StatQuest, another great machine learning, clearly explained video series. Andrew Ng has famous tutorials. He's a Stanford professor, and he has famous tutorials in deep learning. And there's a website called deeplearning.ai. That would be really helpful to get started. And in terms of actual coding, a lot of the deep learning libraries are powered by Python. If you like C++ for some reason, then you could also use C++ as well. But Python is usually the best choice for deep learning. Kaggle has a lot of data sets and tutorials in machine learning for beginners. TensorFlow and PyTorch, which are libraries for building neural networks, have their own tutorials on their websites, but those are going to be a little bit less informative for a beginner. So I would recommend starting with Kaggle. And also experience with, you should start to get familiar with Jupyter Notebooks or Google Colab if you're going to be using Python, because that's going to allow you to basically rerun your code and rerun snippets of your code really easily. And it's just good to get familiar with. And again, I'll be sharing these links. Okay, and on the last note, just some stuff to keep in mind. Deep learning is an advanced topic. I still am learning deep learning, and I'm still learning the ins and outs of it. So truly, really understanding deep learning requires a deep knowledge of linear algebra, which is basically vectors, matrices, and how matrices operate on vectors, linear transformations, things like that. Calculus, because basically training a neural network is the same thing as following the derivative and finding where the derivative is equal to 0 so you can maximize your neural network's performance. And probability theory, because some of the concepts for like what function are you maximizing in calculus, a lot of that is based upon concepts from probability theory and information theory, like stuff like cross entropy and things like that. Lots of scary terms for someone who's never heard all this stuff, but something that I also have to remind myself is that it's okay to take your time to learn these concepts. Most likely, if you are interested in deep learning, it will take you a few years before you start getting really familiar with all the concepts. That doesn't mean you can't get started today, though. You could probably start with small tutorials, small notebooks that try to solve stuff like the handwritten digits problem or stuff like that, that are like the classic pedagogical examples for deep learning. And yeah, so no one expects you to fully grasp these things now. The trick to really understanding this stuff is to deeply understand your fundamentals and build upon them. And this is probably the biggest takeaway I would like to have for this presentation. Don't feel rushed to try to understand something. Really take your time and understand the ins and outs of it, because it's going to pay off later when you're going to try to work on more complex, more involved projects. You want to start by understanding the fundamentals first and take your time with them. Maybe I sound like I'm overstressing this point and it doesn't seem relevant, but I think take it from me, who's done 6 years of computer science at this point. It's really important and it'll help you down the road. Okay, that's all I have for you guys. Feel free to email me. My email's here if you want to talk about possible projects or you're interested in deep learning, you got questions about some stuff you're learning in deep learning, I'm more than happy to respond. I'm in the middle of the interview process, so I may take my time to respond, but I will try to respond to each and every one of you. And yeah, thank you. So I'll leave it open to questions now.
We got a question in the chat. It says, so deep learning requires a lot of mathematical knowledge as well.
So I would say yes. Deep learning does require, understanding deep learning requires mathematical knowledge, because neural networks are composed of a bunch of linear algebra operations, which is a fancy way of saying matrices times vectors, and also some other like probability theory stuff and calculus, multivariable calculus. And these are probably topics you wouldn't even dive into until maybe your second semester in college or third semester. That being said, some of the tutorials I provided are very good at expressing these complex topics in a simple way. And I think that it is definitely possible for you guys to get started today.
We have another question, which is,
You mentioned earlier that deep learning could be used to generate realistic medical data. And I was wondering if there were any other benefits to using it to do that besides ethical concerns and what situations they be used in. Yeah, I mean, the main benefit of being able to share medical data in the first place is that you can build neural networks for other problems or use machine learning for other problems. And I think that's the biggest important thing. If you look at COVID-19 and how this whole situation has affected the world, if usually we don't share medical data, but with COVID, we made a huge exception. The HIPAA, if you guys have heard of that, like prevents you from sharing medical data. A lot of HIPAA rules were waived for the sake of getting a vaccine or like quickly innovating upon COVID-19. And we were able to crank out in a year a vaccine because we started sharing data. And right now we aren't able to do that for pretty much everything else. So imagine like the medical consequences if we could do that. How can deep learning help the environment, e.g. help solve climate change and capturing and storing carbon? That's a really good question. I'm not really sure. I don't think I'm qualified enough to say how it could help exactly. Um, I know that neural networks certainly help in some chemistry applications like protein folding and stuff like that. The repercussions of which I don't understand because that's not my space. But I'm sure that if you looked up deep learning and climate change and stuff like that, you would find some interesting stuff. I watched a video saying that the machine will generate the information in multi-dimensional space of vectors. Does this related to the large amount of neural networks you mentioned earlier? So neural networks are basically, they start off with, like, let's say we were working with an image. An image is like a 2D array, which you can just flatten into a 1D array of just every single row just concatenated together. And that long array is a very high dimensional vector. So you start off with this really high dimensional vector that represents your image. And then you pass that vector through one layer of your neural network. And after that layer, you have a feature vector. So it's some sort of information extracted. Every neuron extracted some sort of piece of information. And we concatenated all those neurons' outputs together to come up with yet another vector. That vector gets put through another layer. And that layer extracts further fine-grained features, finer grained than the previous layers. And you just keep doing that over and over and over. And it turns out that if you look at like some of the final layers of your neural network, you'll actually learn really interesting feature vectors. For example, for one of my projects, I had to take images of some like images like cats, dogs, cars, and stuff, and I passed it through a neural network. And I took the final feature vectors of the neural network and I basically clustered them. And it turned out that feature vectors that were really close together corresponded to images that were visually similar. And images that were far apart corresponded to images that were very dissimilar. So these feature vectors are very informative. I hope that's answering your question. Are multivariable calculus and linear algebra extremely tough? No, I don't think so. I think that a lot of math in general I think math intimidates people, and understandably so. But if you disregard your high school assignments and the pressure of high school and getting good grades, and you just worked at your own pace and you just really try to follow a concept, understanding a matrix multiplication, maybe it takes you a few days to really understand how matrix multiplication works. But at the end, and you will slowly realize the more and more you practice that a lot of these concepts are very simple concepts. When you put a bunch of simple concepts together and call it a mathematical theory, it starts to be intimidating. But if you work at your own pace, I don't think that you would have trouble trying to understand this stuff. How can we incorporate machine learning into mobile applications? What softwares do you recommend? Yeah. So for usually Python is the best has the best libraries in this space. There's something called TensorFlow made by Google. That is like one of the big libraries. There's another one called PyTorch, and that one is also really big in Python. For mobile applications, like if you're thinking like Swift for iOS or Java for Android, I'm trying to think. I know that there must be a way to do it. I would recommend you starting off with Python though. If there's some sort of way to like port your Python software onto Swift or something like that, I think you would be best off trying that, because most likely if you're going to work in this space, you're going to want to learn Python anyway. But I think if you look hard enough, there's probably stuff out there for Swift or Java. No problem. My pleasure.
All
Does
right.
anybody have other questions?
Yeah. Does anyone else have any final questions? I guess not. So thank you so much, Sean. Everyone here, thank you so much for attending. We suggest you all apply what you learned to improve your final product for submission. Good luck on the challenge, and as always, we are here to answer questions on the Terris Challenge Discord. Questions about logistics can be answered by any of the challenge managers, and questions about your projects can be answered by the mentors. Thank you, and have a fabulous day.
All right, thank you all for coming. Please attend our next workshop tomorrow.